So I'm kind of just going to talk over my answer key, and you can always pause the video if it goes too quick. Um, on any type of isotope abundance questions where it's going to ask you to calculate the atomic mass, you're going to make sure that you divide every single abundance by 100, or you're going to move the decimal place 2 places to the left. So that's where I'm getting this 0.198 and this 0.802. And then you're going to multiply it times the mass of each isotope. So that's where this is coming in, and then this is where the 11 is coming in. You have to stop and do significant figures first. Since you are multiplying, there's 3 here and there's 5 here, so this answer had to be 3 total. And then here we had 3 total and we had 5 total again, so this had to be 3 total. And then you add them together. So since you're adding, you are looking to the right only. So since that is 2 to the right, well, actually they both have 2 to the right. So that's where the 2 to the right is coming from here. And then don't forget your unit, AMU. Anytime I ask you which isotope is more abundant, it's always the one that's closer to the atomic mass. So in this case, 14 is much closer to 14.007 than 15. So in 14 was the answer. For number 3, very similar to number 1, I'm giving you the abundance, so make sure you divide both of these by 100, which is what we're doing here, 0.692, 0.308, and then you're multiplying each one of them by its mass. Stop to do significant figures, so since this has the least amount is 3, that's where this 3 is coming from. This ended up being like 19.9. It rounded up, so you had to make sure you kept the 3 significant figures. So that's why I kept it 20.0. Both have 1 to the right, so I had to make sure I kept the 1 to the right there. Okay, so then let's take a look at this one. Number 4 is the same exact thing. You're dividing all your abundances by 100 and multiplying. You're checking your significant figures. I'm trying to think. Oh, common mistake on this is people keep this 0.1 and they don't add on the additional zeros, but you had to keep it. Since this was 4, you had to keep this 4. So just looking at after we get our each mass, adding them together, this has 2 to the right, 3 to the right, 3 to the right, so we needed 2 to the right. So number 5, the mystery element, did the exact same thing here as I did up here. It's just I didn't know what the element was, so all I had to do was go to the periodic table, figure out who has the atomic mass of 55.9. I think it says 55.85 on your periodic table, but that one is iron. Real quick, take a look at an isotope chart just to make sure you're okay. So remember, atomic number, protons and electrons, those numbers are always the same in isotopes. It's the number of neutrons that's changing. So if you ever need to figure out the number of neutrons, you always take the mass number and subtract it from the number of protons. So I would have to provide the mass number to you. And you can always figure out the number of protons by looking at the periodic table. So if I were to give you something like, just pretend the answer key is in here, but something like this, you know that the 19 is your mass number, you know the 9 is your atomic number. So you can easily figure out these 3. Then to get the neutrons, you're doing the mass number 19 and you're subtracting 9. So that's where that 10 is coming from. Let me see if there's something that would be different. Oh, like this one, I gave you the mass number and the neutrons. So to figure out the protons, since the mass number is the protons plus the neutrons, you're just going to do 80 minus 35. Well, 80 minus 35 is 35. So you have to figure out who is number 35. And if you look at the table, it's bromine. So let me know if you have any additional questions on that isotope chart. Okay.